In computing long sums using sigma notation, we have this formula. So formula is equals to n plus 1 over 2. So we have this formula, n I is equals to 1, so c times n. So I have here an example. 4, n is 4, I is equals to 1, 5i. So in this problem, we can solve this like this. 5 times 1 is equals to 5 plus 5 times 2 is equals to 10 plus 5 times 3 is equals to 15 plus 5 times 4 is equals to 20. So we stop in 20 because the n is equals to 4. So 1, 2, 3, 4. So in solving this, we can add this first and last term. So 25 plus 10 and 15 is 25. So it is equals to 50. So in order to prove this, we can use the formula. So in the formula, 5 is the constant 5. We put it outside the sum. So 4i is equals to 1i. So 5 formula is n plus 1 over 2. So Rn is equals to 4. So 5, n is 4. So 4 plus 1 is equals to 5 over 2. So four divided by 2 is 2. So 4 plus 1 is 5. So it is 2 times 5 is 10. So 5 times 10 is equals to 50. So it is the same. Define and evaluate definite integrals. So a definite integral is a type of integral that has both upper and lower limits. It represents the area under the curve of a function between these two limits. So indefinite a to b f at x dx. So here is a and b are the lower and upper limits. A is the lower limits and b is the upper limits of the integral. F at x is the function being integrated, and dx represents the infinitesimal width of the rectangles used to approximate the area. To evaluate a definite integral, one can be used the fundamental of calculus. This theorem states that f at x is the antiderivative of f at x. Then the definite integral of f at x from a to b can be calculated as definite integral of a to b f at x dx is equals to f of b minus f of a. To evaluate a definite integral, we need to find the antiderivative of the integrand, evaluate the antiderivatives of the upper limits, and subtract the two values. So, definite integral are important in many areas of mathematics and science, including calculus, physics, and engineering, as they allow us to calculate quantities such as areas, volumes, and probabilities. For example, in evaluating definite integral, so example, evaluate this problem. So first thing first, we need to find the antiderivative of this 6x, so 6x squared over 2, because this is the power rule. So dx is x plus 1 over n plus 1 plus c. This is the formula of the power rule. So let's proceed. So it is understandable na it has a 1 exponent to 1, so 1 plus 1 is 2, so 1 plus 1 is 2, so minus 4x plus constant c, 1 and 4. So we multiply this into 4, so 6, substitute the value of x, which is 4 raised to the power of 2 over 2, minus 4, substitute the value of x, which is 4 plus c, minus 6, substitute the value of 1, plus c. So here this is equals to 48 minus, sorry, it is minus 16 plus c, minus 3 plus, so 4 minus c. So we can cancel out this c or the constant c. So 48 minus 16, 32 plus 4 minus 3, so 36 minus 3 is equals to 33. So our final answer is 33. So I have here an example. So evaluate this definite integral of 2 to 3 f at x dx is equals to 5, and 3 to 5 f at x dx is equals to 10. So find the answer of this problem. So 2 to the 5th f at x dx. So what is the answer of that problem? So to show to really and to show to you how to really apply the properties of definite integrals. So I have here a graph. So 1, 2, 3, and 5, 4. So 2, 2, and 3. The area of this integral is 5, and 3 and 5, the area is 10. So the problem is we need to find the area of these 2 to 5. So it is simple, we need to add them. So 5 plus 10 is 15. To prove it, we have the formula. So F3 and F2 plus F5 minus F3 is equals to F5 F2. So makancel, crush out that F, positive F3 and negative F of 3. So if we inverse this problem, so 3 to 2 f at x dx and 5 to 3 f at x dx, so it will become negative. So negative 10 minus negative 5. So negative 10 minus, plus, because negative 5 positive 5. So negative 10 plus 5 is negative 5. So this is how to identify and apply the properties of definite integral. Discuss and verify or prove the mean value theorem of integrals. So the mean value theorem for integral states that if a function f at x is continuous on the closed interval a and b, then there exists a number c in a and b such that f at c is equals to 1 over b minus a times integral of a and b f at x dx. In other words, the theorem states that there is at least one point c in the interval a and b such that the value of the function at the point is equal to the average value of the function over the interval. This theorem is extension of the mean value theorem for derivatives, which relates the derivative of a function to its rate of change at a specific point. The mean value theorem of integrals relates that integral of a function to its average value of an interval. The mean value theorem for integrals has many practical applications such as physics, economics, and engineering. It can be used to calculate the average value of a function over a given interval, which can be used in determining the total amount of some quantities over the interval. So the mean value theorems for integral is a to b f at x dx is equals to f at c times b minus a. So I have here an example. So f at x is equals to x squared. So where a is 0 and b is 4. So let's solve this problem. So we have this formula. So a is 0 and b is 4 x squared. F at x is x squared. So let's substitute the value of that dx. So c is c squared and b minus a is 4 minus 0. So power rule, 2 plus 1 is 3. 3, 4. So 4 minus 0 is 4. C squared. And substitute the value of x. I mean 4. So x is equals to, this is 4, times raised to the power of 3 over 3 minus 0. So 0. So 4c squared. So move here up. So 64 over 3. So it's understandable na siya. 1/4 4c squared 1/4. So crush out the 4. So the remaining is 64 3 square root of c. So let's square this problem. So positive negative 4 square root of 3. So crush out c. So c is equals to positive negative 4 over 3, or is equals to 3 square root of 3 over square root of 3. So let's get the decimal point. So 2.309. So the final answer is 4 square root of 3 over 3. Discuss and verify or prove the fundamental theorem of calculus. So the fundamental theorem of calculus states that if a function f at x is continuous on the closed interval a to b, or a and b, and f at x is an antiderivative of f and x, then definite integral from a to b f at x dx is equals to f at b minus f at c. In other words, the definite integral of a function over an interval can be evaluated by finding an antiderivative of the function and then subtract the values of the antiderivatives at the endpoints of the interval. This theorem is extremely powerful because it provides a practical method for evaluating definite integrals. It allows us to avoid the tedious process of evaluating a limit of Riemann sums and instead find the antiderivative of the integrand and evaluate it at the endpoints. Moreover, the theorem provides a connection between the two seemingly unrelated concepts of differentiation and integration. It tells us that differentiation and integration are inverse process of each other and that integration is essentially a reverse of differentiation. Overall, the fundamental theorem of calculus is a fundamental result in calculus and it is used extensively in many areas of mathematics, science, and engineering. So I have here example of fundamental theorem of calculus. So example 1 is d over dx, definite integral of x from x to 4 square root of t3 t2 t raised to 3 plus 5 dt. So our f at t is equals to square root of t raised to the third power plus 5. So d over dx, definite integral of x from x to 4 f at t dt is equals to d dx. So f at t for x to 4. So d dx f, substitute the value of 4 in RT. So f and x, so equals to 0 minus f at x. So our answer is negative x raised to the power of 3 plus 5. Another example of fundamental theorem of calculus is this dx, d over dx, definite integral from 5 to x squared square root of t3 t raised to the power of 3 minus 4 dt. So our f at t is equals to t raised to the power of 3 minus 4. So x squared raised to the power of 3 minus 4 2x minus equals to 2x square root of x raised to the power of 6 minus 4, and so dx, d over dx is equals to direct integral from 5 to x squared f at t dt is equals to d over dx is equals to f at t x from 5 to x squared. So RD, so f, so x squared, subtract the value of the x squared, so x squared minus f, so subtract the value of the t is equals to 5, and it is equals to fx fx to the power of 2 times 2x is minus 0. So fx squared square root of x raised to the power x squared raised to the power of 3 minus 4 is equals to square root of x raised to the power of 6 minus 4 to x. So it is the same in this answer. So same lang silag answer.